Hello and welcome back to the channel. In this tutorial, we will learn about recursive functions in Python. So what is recursion? Recursion is a common mathematical and programming concept. In terms of functional programming, recursion means that a function calls itself. Python allows a function to invoke itself, as you can see on the screen, that we are defining our own custom-defined function that invokes itself or invokes recursively and is known as recursive function. So let's get started by looking at some simple examples. So let's start with something really simple. This first example I'm about to show is based on a question posted to me by one of my followers by the name Lirit. In this function, I'm going to add all the non-negative numbers starting from the user provided value n down to 0. So this is a recursive addition function. If n equals to 1, we'll return n, else we'll return n plus function n minus 1. And we simply make a call to the function inside a print statement. In this case, we're doing function 4. Let's give it a try. And when we run this, we should get 10. So what is happening here is that the function call is happening within the print statement in line 10. When we invoke the function with function 4, the return n plus function n minus 1 will return 4 plus function 4 minus 1, which is equivalent to 4 plus function 3, and that is equivalent to 4 plus 3 plus function 3 minus 1, which is equal to 4 plus 3 plus function 2, and similarly that's equal to 4 plus 3 plus 2 plus function 2 minus 1. And if we recursively do that, we end up with 4 plus 3 plus 2 plus 1, which is equal to 10. So we are basically adding 4, 3, 2, and 1 and getting 10 as an output. As you can see, the function n will return 1 only if n is equal to 1. Otherwise, it will return n plus function n minus 1. This is an example of classic recursive function where we can call the same function n within its definition. So here we define function n and we call that function with a different value of n minus 1 in this case, inside the definition of that function. So long as the number n is not equal to 1, at each invocation we will decrement n by number 1 and add it to the previous returned value. Note that in this case, the recursion will stop only when return 1 is reached. In other words, as long as return 1 is not reached during execution, the recursion will invoke the function again and again. This will sometimes result in a situation where the recursion will reach the maximum threshold. For example, if we modify line 10 with a negative 4 and run it again, we will end up with maximum recursion depth error. That is because we never reached line 5 return 1 statement because we started with a negative number and every time we are decrementing by negative 1 each time the recursion occurs. We can try the code with 0 or any negative number and the function will loop until we reach recursion error, as you see in the screen. If you have made this far into my video, it's probably because you like the content and it's helpful information for you. So please don't forget to like, share, and subscribe. Let's talk about a few things to keep in mind when we use recursion or recursive function. First thing to keep in mind is that recursive function is similar to while loop because the proper use of a recursive function requires an exit strategy like in a while loop. The main difference is that we use function to repeatedly call our codes instead of a proper loop. In this case, when we run this code, because we are starting with a negative number, we never reach n equals to 1 exit point is never reached. Also keep in mind that the maximum recursion is there to sort of check the memory uses and prevent crashes, which is not there in a while loop. Maximum time a recursive function can be called is 1000 by default, but that can be changed if needed. Last thing to keep in mind is that when we use recursive functions, all the returned value from intermediate function calls are cached in memory, and all that calculations are shifted to the end before exiting the main function call. This makes the recursive function take up more memory space and even be inefficient compared to a for loop or a while loop. Let's take this example of recursive addition that we did and make it a little bit more complicated with multiplication function here. So that would be a recursive factorial function. So instead of a generic function, I will say factorial n. What factorial means is for the given value n, we would need to multiply n all the way down to 1. So if n equals to 4, we would do 4 times 3 times 2 times 1 and get a result of 24. And the base cases are factorial of 1 would give us 1 and factorial of 0 would give us 1 as well. So let's create the base cases first. So instead of n equals to 1, we will say if n in the list of 0 and 1 we will return 1 in these two cases. Else we will return n times factorial n minus 1, and we will call that here. Let's see factorial 4 and run it. We get 24, and that seems right because 4 times 3 is 12, 12 times 2 is 24, so that's our result. Now what do you think will happen if we enter 0 here and see? So factorial 0, like I said earlier, should give us 1, and that is the case. Factorial 1 will give us 1, and factorial 2 will give us 2. Factorial 5 will give us 120. So our code seems fine. The only problem here is it is not well suited to receive negative numbers. So if we do -1, let's say, then it would go to maximum recursive depth. And that's because we haven't taken care of what happens if n is a negative value here. So let's put that in as well, and that should take care of that. So if n is less than 0, we will simply return none. Let's put that in next line. And now let's run it again, and it will give us none. Let's try some base cases. Factorial 1 is 1, factorial 0 is also 1, factorial 5 again is 120. So that is how we would use recursive factorial or recursive function to create or to calculate factorial n. The third example I want to discuss in this video is the Fibonacci number or the Fibonacci series. The Fibonacci series is very useful in computer science and engineering, as it can be used to model population growth in bees, bunnies, and many other animals. It can also be implemented to understand patterns of seeds and petals in flowers, like sunflowers, for example. There are numerous implementations of Fibonacci series. Basically, the series starts with 0 and 1, and thereafter, the next number will be the sum of the last two numbers. Therefore, the third item will be 0 plus 1, which is equal to 1, and the next item will be 1 plus 1, which is equal to 2. For simplicity, we can say that the series starts with 1 and 1. The base cases will be the first two items, the two instances of 1. So when we come back to PyCharm, let's say Fibonacci series function will be named as Fibonacci. Let's consider the base cases first. For values 0 or less, the series is not defined, and the first two items are 1. So if, let's say, n is less than 1, we will return none. Elif n in 1 and 2, then we will return 1. So the first two items will be 1 based on this, and if n equals to 0 or less, then we will return none from this. So if and then else, in the else case, we will return the last two items, which are Fibonacci n minus 1 plus Fibonacci n minus 2. And then we will simply make that call, make the function call. This time we will do inside a for loop. So let's say for n in range, we will start with 1 and end at 10. So we will have to put in 11 in the range function. We will say print number n and the Fibonacci of number n. That should be our code. Let's give it a try. Now we see here the first item is 1, the second item is also 1, and from the third item onwards we keep adding the last two items. So we got 2 because the last two items are 1 and 1. So 1 plus 1 gave me 2, 2 plus 1 gave me 3, 3 plus 2 gave me 5, 5 plus 3 gave me 8, and so on. So we got the values up to n equals to 10, and that is how we do Fibonacci series using recursion. So just to recap, when a function calls itself, this situation is known as recursion, and the function which calls itself is called a recursive function. We can use recursive functions in Python to write clean, elegant code and divide into smaller, organized chunks. On the other hand, we need to be very careful, as it might be easy to make mistakes and create a function which never terminates. We also need to remember that recursive calls consume a lot of memory and therefore may sometimes be inefficient. I hope this video was helpful and that you learned something new. If that's the case, don't forget to smash that like button. Also, don't forget to share and subscribe to the channel if you have not already. If you have any questions, don't forget to put them on the comment section below and I'll try to reply as soon as possible. As always, until next time, thank you.